Hey guys, welcome back. Today we are continuing with our unit on acids, bases, and solutions. The past couple of days we've been talking about acids and bases, and now we're moving away from that and we're talking about solutions and solubility. So without further ado, let's get into it. So today we're going to be able to determine the solvent and the solute in a solution, and that's really going to be what we're focusing on today, figuring out the difference between the two. Okay? So you guys did a survey at the beginning of class today, and you had to tell me, number one, what flavor of Kool-Aid is the best, and why is the answer strawberry kiwi? And then number two, how do you like your Kool-Aid, right? So if you're going to go to somebody's house or you're making Kool-Aid and you're going to drink it, what color do you like it to be? For me personally, I like it around a 3. And that's because it's like the perfect mix of water and Kool-Aid mix, right? If you're down here at the 1, it just tastes like water. And if you're up here at 5, it's way too sugary, way too much of the mix, and it just tastes like powder. So this has to do with dilutions and concentrations. So as we go from 1 to 5, the concentration of the Kool-Aid mixture increases. So there's more powder in the water. And that's what we're going to be talking about today. Solubility, solutes, and solvents. Okay? So first off, what is a solution? Because Kool-Aid is actually a solution. So it's a homogeneous mixture. If we go back to Unit 1 when we talked about homogeneous, heterogeneous mixtures, remember homogeneous is the same texture throughout. So what we're talking about, like with liquids and drinks and all that, it's going to have the same texture. So the solute is the substance being dissolved, and the solvent is the substance doing the dissolving. Now, most of the time, the solvent is going to be water, and the solute will be something like, a chemical compound, salt, sugar, which are both chemical compounds. But Kool-Aid, powder, drink mix, something like that will be the solute. Examples would be salt water, apple juice, dust-free air is actually a homogeneous mixture. It's a solution. With dust in it, it would become heterogeneous, but we're assuming if it's just air, it's a homogeneous solution. So the solute, again, is the substance that's being dissolved, usually in the lesser amount, and then the solvent is the substance that dissolves the solute. So solute plus solvent equals solution. Okay, and there are some examples here in this chart on the right as well. So the universal solvent is actually water. So water is a versatile solvent because of its attraction to other molecules, just meaning that there are so many compounds that easily dissolve into water. If you make Kool-Aid or sweet tea or coffee, the base of it is always water, right? You start with water and you add something to it, which will then dissolve into it and make a solution. So solvent is going to be the water in most cases, and then the solute is what's being dissolved into it. And those substances dissolve due to particle attraction. Basically, water is a really good solvent. The particles can overcome their attraction for each other and then be attracted to the water, and so you get this homogeneous solution once you mix it up. And here as an example, so we're making sugar water in this picture. The solute is the sugar. It's going to go into the solvent, which is water. Stir, 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 dissolve. Once all the sugar is dissolved, you have this solution of sugar water. So the solution is the sugar water, the solvent is the water, and the solute is the sugar. Okay? Here's a way to remember that, because it can be a little bit tricky to remember solute versus solvent. So the robber hid the loot in the vent. The solute goes into the solvent. So like the example here would be salt water. The salt is the solute. The water is the solvent. Remember, the robber hid the loot in the vent. Loot goes in the vent. Solute goes into the solvent. And there are 3 different types of solutions that we need to know about. Unsaturated solution is when more solute can be dissolved. So you have pretty much space to dissolve some more of that solution in there, or dissolve more of the solute in there. Saturated solution means no more solute can be dissolved. So it's basically at the point where it's the perfect amount of solute per solvent concentration. And then a supersaturated solution is when there's too much solute dissolved and crystals start to form. So if it's supersaturated, super just means above. It means there's just too much solute in the solution. Okay? And that is going to be the end of the lesson today. It's just an intro to solubility. We need to be able to identify solutes and solvents. What we need to make sure we know is that dilute goes in the vent, right? Solute goes in the solvent. So most of the time the solvent is going to be water. Water is the universal solvent. But solute, an example would be like sugar, salt, Kool-Aid, Powerade packet, Crystal Light, if you guys have ever seen those Crystal Light packets. Those are all examples of solutes that can be dissolved into solvent, and particle attraction is what allows that to happen. Okay, so pretty short lesson today, just an intro. We're going to do some more with solutions and solubility over the next couple of days, but for now you guys are good to move on to your assignment for the day.